Okay, and we're live.
Hopefully.
Yeah, welcome to the Tuple Talks by 11 Sigma talk show, so to say. My name is Miszczyszyn, and my co-host today is Jakub, Rożek. And we'll be discussing the data validation in TypeScript, talking about some libraries and some concepts. So, Jakub, how are you doing?
I'm fine. I'm in a freezing Ukraine right now, so I'm actually pleased that I can spend that time at home instead of going out and freezing. So yeah, I'm doing well.
Cool.
What's up?
So before the live, you sent me some links that you wanted to talk about. Let me just ask you this question first. Which library for validation is your favorite in TypeScript?
Well, actually, I mostly use plain JSON schema because, well, first of all, I happen to work at a company that kind of builds tooling around JSON schema. So okay. that format is basically the closest to my heart, and this is primarily why I happen to use plain JSON schema without any like fancy library. But that doesn't mean that you shouldn't use any libraries, because one of them that I actually linked built on top of JSON schema, which is basically brings like a higher level TypeScript like interface for building JSON schemas. And this is the I think TypeBox, that library. So overall, JSON schema is the closest to my heart, but it's much more than just data validation. Because for instance, the tooling that we built is also used for data modeling. So JSON schema is basically way more than just data validation. But yeah, it's my closest, like my favorite pick, basically. So, but it's not the only one.
So basically, the concept behind the JSON schema is that you use JSON to specify JSON, right?
Yeah, exactly that. I mean, most of those libraries, maybe besides ZOD or ZOD, are meant to validate JSON. They are really capable of validating some JavaScript constructs, like let's say maps or functions or something like that. They can primarily validate JSON. So they're basically limited to certain stuff like strings, numbers, nulls, plain objects, plain arrays, and all that kind of stuff. We cannot, for instance, validate sets, for instance. Yeah. So yeah, they're basically limited to JSONs. And the way it works, you usually specify. JSON schema is basically a set of keywords you specify, and those keywords determine the way a given input is supposed to be validated. So for instance, in this particular case where we have that example, you specify, maybe let's scroll a bit up because it's the simplest one, this one. So basically you specify that you expect an array, and that array has to consist of numbers. So that's like the very basic scenario, which is actually not that uncommon. And on top of that, right, we can also specify, if you scroll down a little bit, we should see some additional keywords. Maybe even, yeah, for instance, but you can scroll even further. Like this is the.
Yeah, there are a lot of them, like objects.
Yeah, but I mean, for arrays, you can like, because you can also specify. It actually goes a bit like outside of types, because in types we cannot quite specify the maximum length of an array. I mean, you could technically type it, but it would be tedious if you had, let's say, 100 items. It would be somewhat hacky. I mean, it doesn't provide like a. It's not supported out of the box. That's what I mean. And in JSON schema, you can actually specify that your array has to consist of, let's say, 3 items, or it must contain it may contain up to 100 items. So you have also a keyword like unique items, which means that each item in an array has to be has to be unique. So basically, JSON schema, you cannot like represent every JSON schema in a TypeScript, like using TypeScript interfaces, using TypeScript types. But that doesn't mean that this is a bad format to for validation, because I mean, it's usually sufficient to just specify that you expect an array of numbers, and in TypeScript you can actually define that you expect some minimum items. I mean, if it's like up to 5, for instance, because you can just use indices, and that will be sufficient. So overall, it doesn't mean that you cannot use JSON schema with TypeScript. There is even actually a fancy library called JSON Schema to TypeScript, which I see you have open. So basically, the way it works, you provide a JSON schema, and it outputs you the TypeScript typings. I think there is an example under input. So yeah, basically for the following JSON schema, you receive the TypeScript interface which you can use later on. And the reason I like JSON schema is because you can also use it for stuff like load testing or fuzzy testing, because you can, for instance, use those JSON schemas to generate some random data. So it's actually it's just very useful, not just for validation, but for other use cases. So that's why that's one of the other reasons that I happen to use JSON schema.
Also,
and
what I like about JSON schema is the fact that it's JSON, so you can save it in a text file. You can send it over the API in a response or whatever. So
exactly, that's
just JSON.
Yeah, and what's actually even better is that you can most of libraries support HTTP. So basically, you can serve that JSON schema over HTTPS, and that means that this can be consumed by other tooling, not that the one that's written in TypeScript or JavaScript, but also in Java, C#, whatever. There's plenty of different implementations, so it's just very portable, and it's not just limited to TypeScript. It might be actually one of the like factors when you say have some enterprise grade projects that have a number of various technologies involved, because you can use that JSON schema, you can exchange the JSON schema with a number of teams, for instance. While if you use some TypeScript only library, you are usually limited to that language, which sometimes is a deal breaker if you really want to reuse that definition. But obviously, I mean, since JSON schema is very popular, you have a lot of tools that makes it easy to integrate it with TypeScript. This is one of my favorite ones. I use it quite often because JSON schema doesn't provide you the TypeScript typings out of the box, but this one lets you create it. And actually, TypeBox, the other project that you have open, which builds on top of JSON schema, is a very cool example. Because if you scroll down a little bit, there is a usage. Yeah, so basically the way it works, it's somewhat similar to IoTS in some sense, because you use some like more abstract constructs to build JSON schema. And the way it's brilliant is because you get the like all the advantages that TypeScript brings you. You have like out of the box typings and everything, like in like this one, and you can still use you can still serialize it back to JSON, for instance, if you wanted to save it in a file. And since it's just like a JSON schema under the hood, you can still use all the validators and everything that are out there in the ecosystem. So I would say that if one would like to start with JSON schema, TypeBox would be probably the best place to start, because it actually kind of tries to follow the TypeScript types. Like if you see over there, I mean, there is like a concept. You have like unknown, any. This obviously doesn't quite exist in JSON schema. I mean, it exists, but it's named differently. Have literal, union, intersect, record, and all that stuff. So basically, it provides you with the naming that's present in TypeScript, but under the hood it maps it to the internal representation that JSON Schema supports.
So basically, it connects, it joins the advantages of both JSON Schema and TypeScript.
Exactly. Because you have basically there is no learning curve involved pretty much, because the naming should be very familiar, because you have like read-only, object optional. This is all inspired by the constructs that are like native to TypeScript. Mm-hmm. But under the hood, it gets mapped to the actual JSON schema, which you can then use with other tooling. So this would be like my bet for all the TypeScript developers that would like to use JSON schema, because they need to, or they have other tooling that supports it, but doesn't really want to learn it. This would be perfect. In my case, it's a bit different because I happen to work for the tooling for JSON schema, so I'm quite familiar with it. But but overall, this would be great. And actually, it's worth mentioning that JSON schema is quite commonly used. I mean, people might be not that familiar with it, but like the most common validator, AJV, is probably one of the most popular dependencies. Like I swear that almost everyone. I mean, stars may not quite reflect it, but if you like looked up the NPM downloads, this would be counted in millions, and it's actually supported by one of the biggest companies. And the reason they support it is mostly that this project is vital to the ecosystem, because you have stuff like ESLint that uses it, Webpack, they all use it. And if that library would be deleted, for instance, one day, pretty much every project that relies on ESLint or Webpack would be broken unless they switch the library. So overall, although you might be not using JSON schema directly, plenty of your dependencies do for all the validation. For instance, in the case of ESLint, plugins, like the options that each plugin takes are described using JSON schema. So I mean, it's really not uncommon. Basically, it's a very popular concept that's used. So that's why I actually started with JSON schema, because there's plenty of resources available. You have great tutorials, plenty of toolings for almost every language.
Also, I believe that this tool is not only a validator; it's also a compiler, isn't it?
It is. It's a code gen. Yeah, exactly.
Yeah, you can use the AJV, or however you're supposed to pronounce it, to actually compile your JSON schema and generate the JavaScript code that does the validation, and it's really, really, really fast.
It is.
I'm the author of one of the validation libraries, and I tried to compare to AJV, and it's not even close.
Yeah, it's very fast, and then another benefit of that is that you have that code generated, and therefore you don't really have any like runtime costs. That's because CodeGen itself isn't the whole process of CodeGen is rather slow. So the fact that you can pre-parse that schema, generate the code, and just then execute that code later on from a plain file is great. And yeah, I mean that library is really, really decent. But this is just one of many. There is like, I think 10 or 12 implementations just in JavaScript or TypeScript. So I mean, it's really easy to find something that fits your needs, and that's why JSON schema would be like my preferable pick.
Also, I think it's worth noting that JSON schema is not only used for validation, like you said, but it's also used for specification. For example, you can write modeling. Whole documentation of for example, your REST API in JSON schema.
Yeah.
And I think this is what OpenAPI or Swagger use for
yeah, they do. Yeah, we built tooling out of for it. There is actually stoplight listed somewhere, I think.
Yeah.
It's like we use it like quite everywhere. So yeah, it's useful for data modeling. As I said, there is stuff that lets you generate some random data based on JSON schema. So it's a perfect choice for fuzzy testing or load testing because you can really generate megabytes of data very easily. So yeah, I mean, you basically write that schema once and then you can use it for a number of cases. Like as you said, documentation, validation, testing, pretty much everything. So that's why it's just very powerful. I mean, it's not just useful for validation, but it's just way more than that. But it's not the only choice.
So we can use TypeBox to generate the JSON schema because it also provides nice TypeScript interface. But then you can also use AJV to validate the actual data, right?
Exactly. Or you can, or if you don't want to use TypeBox for some reason, you can just write JSON schema by hand and then use a project like JSON schema to TypeScript that generates TypeScript interfaces out of it. So, I mean, you have basically at least two choices. But I would say that TypeBox is probably the easiest way to go with because it provides constructs that are familiar to every TypeScript developer. And there is like no learning curve involved. So I think that's and you still have all the benefits of having JSON schema because that's what the internal representation is. So that's why I would recommend it. The JSON schema to TypeScript is probably more useful if you already have some JSON schemas and you don't really want to rewrite them using TypeBox because you cannot, for instance. I mean, that there is some other there is some model tooling in your ecosystem, in your project that, for instance, isn't written in TypeScript. So we just cannot quite use TypeBox. So this would be like the second choice if you just cannot use TypeBox but still have TypeScript project and would like to benefit from typings, then you could use this.
Okay, but if JSON schema is so great, so why do other tools even exist?
Because like I mean, JSON schema might be too much. Like I also linked JSON type definition, which is like pretty much a subset of JSON schema. And if you really have like small needs, you don't need anything powerful. You can use something simpler, and that's why JSON schema, a JSON type definition, for instance, exists. It's just much easier to learn, easier to process, because you have only like JSON schema has, I don't know, 30 or 40 various keywords that you can use, and overall the learning curve isn't small. But JSON type dev, you could probably learn it in 5 minutes or so, because it's just a very simple concept that will cover like 90% of cases. So it's not that popular, and there isn't that much tooling. But actually, the integration with TypeScript is not bad because they put a lot of focus on that. So if you need something like really simple and you start from the scratch, like you don't have anything, this might be also not the worst choice.
Honestly speaking, I never heard of it before.
Yeah, I mean it's less popular. That's for sure. But it's not bad because like they provide a number of tooling out of the box. Like you have a tool for fuzzy testing. Like if you click on implementations, and there will be some. There is like a set of tools that you can use. Like the AGV supports JSON type dev, so you can use it with AGV. Yeah, there is some tooling
Java,
like
Golang, C#,
Ruby,
Rust.
The integration isn't bad overall, but obviously the choice is a bit limited if you compare it with JSON schema. But I mean, it's much simpler. So if simplicity is one of the constants here, basically you wouldn't like to maintain large JSON schemas, and you only have simple objects, then this might be a nice choice. And I would say that JSON type def might be actually better for data modeling, because we have stuff like discriminator, something that isn't quite supported by JSON schema. It's supported by OpenAPI, but not by JSON schema. And discriminator, I think, is really the presence of discriminator might be really helpful for data modeling, because it's like makes it easy to follow.
Also, what I really like is that there is a tool called JTD Infer that allows you to generate the schema out of the actual data. So, for example, you have a JSON file or a, I don't know, REST API response. You just put it into the JTD Infer and you get back the validator.
Yeah, it's really useful if you have
really
existing data. Right? Yeah, exactly. I mean, it probably won't work for like super complex objects, but if you have super complex objects, you probably have other problems to care about. So, I mean, this isn't really bad. I mean, and
you can also just use it to get started and then modify it manually.
Yeah, exactly. And if you actually there is a page, learn JSON type def in 5 minutes or something like that. So if you could open it, you would actually see that it's very similar to JSON schema. I mean, it's not the same, but it's very close. So what that means is that you can start with JSON type def and then easily convert it to JSON schema if you needed to, because it's a very similar concept, more or less. There are some like slight differences around naming and such, but overall it isn't that terribly difficult to convert it to JSON schema later on. While converting JSON schema to type def, JSON type definition would be probably well, impossible at times. So that's why, you know, this might be not the worst choice if you prefer simplicity and still benefit from some nice integration, because as we said, it's not that TypeScript that has some tooling around it, but there is also other languages which probably might be crucial for enterprise projects, which oftentimes,
because the JTD code again, I opened the TypeScript generator article, but there are plenty of more.
Yeah.
Like we said, Golang, Ruby, C#, Java. It can
Rust.
generate Rust models for basically the types for, well, most of the popular languages.
Yeah, exactly. And that's why, for instance, like switching back to some like TypeScript first libraries like IOTS, I think the main drawback of them is that I've never really seen any like they are mostly like oriented on TypeScript or ZOT or ZOD. They're mostly oriented on TypeScript, so you're somewhat limited to that language. But the big advantage of them is that while JSON type definition and JSON schemas are limited to JSON, this lets you lean a little bit more if you needed to. Obviously, like JSON is still every data type that's supported by JSON is like the preferable way of validating that, if you know what I mean. But you can still write your own like tags. Like if you wanted to validate sets, it's much easier to do that using IOTS than JSON schema or JSON type def. Because JSON type def is impossible. So
I think IOTS is mostly meant for people who use functional programming.
Yeah,
it works really well with FPTS, so it's another library from the same person. And
it works great.
It introduces a lot of very academic functional programming Haskell-like concepts. So I'm not sure if this is the most pragmatic way to do it, but it's definitely the way to do it if you want to use functional programming.
Yeah, you can. If you need some, like if you ever wanted to see some example, you can refer to stuff like Prism, because we actually use FPTS there and also IOTS. So
yeah, we also use
I mean
FPTS and IOTS at Breeza.
Yeah, exactly. It's like these are like brothers, like siblings going hand in hand, pretty much. But and honestly, if you take a look at T-type, I mean, it's very similar to TypeBox. It's not that far off. It's not exactly the same, but the constructs are somewhat similar. I mean, they aren't the same because like you have partials, and as you said, it's most of the examples involve FPTS, so it might be not that someone is not that experienced and mostly rely on copying examples from README and such. IOTS might be not that approachable because most of those examples involve FPTS. But I mean, still, if you already have FPTS and don't have any other language in your pipeline, don't really need anything else. Like you just need validation and nothing else than that. No data modeling, no like random data for testing or anything like that. Then, I mean, IOTS might be a good choice. I mean, it's probably the best choice if you have FPTS because it's just so well integrated and just pretty much works out of the box. So this is another option. And the last one.
Yeah, there is one very popular library nowadays that's called Zod.
Zod, yeah, exactly.
It's the name comes from I think TV show or something like that.
Yeah, I don't know. Actually, I've never really actually, I'm not sure. It might be actually, but overall, I mean, it's yet another library that tries to solve the same problem, but it's mostly like it's TypeScript first. So that's
but you also get some interesting libraries around this, like JSON Schema to Zod or Zod to JSON Schema, which is interesting.
Yeah, which is good, but I mean, like this makes things a bit more complicated. I think, like if you need to like if you have JSON schema and you need to add some converter, it's usually some extra step that in your pipeline that you might not want to have. But overall, I mean, the concept is not that different from IOTS. Like they all look pretty familiar. So it's pretty much a matter of taste, I would say.
Also, I think it's more popular because of the front-end developers, because Zod got integrated with React Hook Form or Formic. It's also used in Blitz.js, which is a fork of Next.js, so to say. So
yeah, I mean it's
really lightweight, so that matters for the client side, right?
Yeah, exactly. We actually considered using that for one of our projects, which would only involve validation. And yeah, as you said, like if size is the factor, then sort might be not the worst choice. And there is actually, I think, like a comparison table at the bottom, because there is some other like libraries like Cube that also integrates well with, or maybe it was actually, I think it's over here. So
yeah, I used most of them, like Joy. It's great.
Yeah,
it used to be great, but doesn't support TypeScript. Yep, it's also cool, but some of the things are not really correct in TypeScript. And then IOTS, like we already discussed, it's a completely different approach.
Yeah, because it prefers functional programming. So, but I mean, like if you compare those examples, like the IOTS one and the Zod one, they aren't that much different.
Yeah,
I think the naming is, but overall the way I mean, it's really to switch. That's what I mean, like from Zod to IOTS if you needed to. So that's, I think, something that also may potentially matter if you have a mixed code base, because at times, like we have such a mixed code base where some of the code uses functional programming and some not. So it's still good to know that these libraries are quite, maybe not quite, but they are reasonably close. So you can try to exchange it one with another.
Yeah, exactly. And there are many more different libraries, less popular.
A lot of them.
Runtimes or many more.
Yeah, but I usually, when it comes to such libraries, I usually tend to look at popularity. I mean, I know it's might be not the best metrics, but they're usually, most of them have a similar set of functionalities, so it's not really a concern. There might be one or two nice features that one library lacks and the other has, but overall the popularity means that you have more resources. It usually means that you have more resources, more questions asked on Discord, Stack Overflow, and all that kind of stuff. So if you have more juniors on your team, for instance, you don't really need to rely on documentation itself. And you can, you have more resources available, which is oftentimes really helpful, because, sometimes the documentation isn't that great. And if you run into some issue that nobody else has run into before, you might spend a lot of time on that. And it might be just a bug in that library, which obviously isn't something that you would like to see if you use a data validation library and it has some major issue. So that's why having something popular that's also supported by other languages and has plenty of different tooling around it it's usually better, I would say. So yeah.
Let's quickly compare. I mean, it's like you said, it's not really the most important thing, but for some people it might be the number of stars on GitHub for each of them.
Yeah.
So for Zod, this is 5,000, over 5,000. For TypeBox, it's only 1,200, and for IOTS, it's around the same as Zod. And then for AJV, it's 10,000. So it's like twice as popular.
And AJV is really like bulletproof because it's used by plenty of heavy players. So it's just, it's battle tested basically, and JSON Schema is just quite powerful, and you have plenty of integration. So I would still say that if you don't use functional programming, don't have any you don't really need that forming integration or other like React form hooks integration or whatever that some of the other libraries provide you out of the box. Using TypeBox, for instance, if you don't want to write JSON schema by hand, might be a good choice. And the reason TypeBox doesn't have that many stars is probably also because it's relatively new. I think it's not such a like old library. I think it was written like 2 or 3 years ago, so it isn't that old. So I mean, it's good to know it exists, and in the end of the day, you should choose the solution that fits your needs the most. And each project is different, but usually I think the number of integration may matter. The reason the primary reason I choose JSON schema is that I can just reuse that schema for a number of cases, like documentation, fuzzy testing, load testing, and all that kind of stuff. So I just avoid but just saves me time basically in the longer run, because it might take a little bit more time to write a JSON schema, but then I just use it everywhere, and I don't really need to touch it too much, and don't need to have many other concepts in my project. Just one one format to rule them all, basically.
Yeah, I think it's a great sentence to sum up what you've talked about today. Because we are running out of time, we want to time box it to 30 minutes. So thank you, Jakub, for sharing your knowledge about the data validation in TypeScript. I'll obviously add all the links in below the video in the description. And yeah, watch us every second Tuesday at 12 p.m. On our channel. Like and subscribe. And again, thank you, Jakub, and see you around.
Thank you for hosting. See you around. Bye-bye.